Today's presentation will be on silviculture and silvics. First, a couple of working definitions. Silvics is the term used for the characteristics that define the life history, growth, behavior, and ecology of a tree species. Silvics describes all aspects of a tree species life cycle, from germination to death, including the environmental and soil conditions that are suitable for its growth and the insects and pathogens that can harm it. And we're using the term out of the Encyclopedia of Forest. Silviculture, on the other hand, is the application of silvics, that is, the use of principles of silvics, to the management of trees in order to enhance the reproduction, survival, or growth of a specific tree species. So silviculture is managing trees based on the silvics, or growth characteristics and need characteristics of trees. So it all relates to silviculture. But why would we practice silviculture? Well, there can be a number of reasons. We can practice silviculture simply because it's the right thing to do. That is, we're stewards of the land. We're practicing stewardship. We could be practicing silviculture because a policy dictates it, such as for our national forest. Or we can practice silviculture as a part of forest management to achieve landowners' goals. And that could be different depending on whether it's forest industry or non-industrial, and we often use the term non-industrial private forester landowner, or NIPF. Well, let's talk about wood utilization and using silviculture for the purpose of enhancing wood utilization. When you do that, it's aimed at growing useful trees. Now, useful can be for many purposes, different purposes. Silviculture also can do some of the following things. It can set up timing for future operation. It can, when done correctly and for the purpose, set the stage for efficient harvesting. And hopefully, silviculture, because you're using good practices of silviculture and because it's based on correct silvics, can simultaneously maintain the productive capacity of the site and vegetation to produce more. So this incorporates the idea of sustainability. Well, managing for wood utilization depends on a number of things. One of those is the history of disturbance. We'll talk more in a minute on that, and we've talked about it in past videos. Also, it depends on the availability of contractors or labor. For instance, some landowners who are wanting a softer touch and look to their forest land, such as doing individual tree selection only, may find themselves constrained because there are not contractors who have a scale of smaller scale equipment and trained labor to do that kind of work. Of course, we will mention this throughout the entire semester as we talk about woodland stewardship. Ultimately, everything gets back to what a landowner's objectives are, and we saw from earlier slide and an earlier presentation when we looked at reasons for owning land, those objectives can be quite diverse, and they can have multiple objectives. Wood utilization also depends on the tree species that are present, and usually it's going to be a species mix, or can be certainly, and the harvesting and regeneration systems that are preferred. And we'll talk about different systems and why a landowner may prefer to use one over the other. And ultimately, it depends on the particular timber products that we desire to produce and whether the markets exist for them and whether they're robust markets or not. Well, we mentioned disturbance, and this is a revisit to earlier presentations. We As noted, but prior to European settlement, fire was used for clearing land, improving wildlife habitat, and hunting, and it created a shifting mosaic of open grasslands, woodlands, and close forests with widely scattered villages. Then, with the Europeans and land settlement and land clearing, some fire was used, but not in the way it had been previously. It was mostly used for improving forage for livestock. And then in the 1880s and early 1990s, we saw the arrival of the railroad, industry moved in, forest industry began to buy large tracts of forest land, especially in the 1900s, and we saw exploitation of forest resources. The 1930s, the 1970s, we saw the emergence of fire suppression in Smokey the Bear. Largely this was created by wildfires and concerns. And from the 1980s to present, one of the biggest factors that we see is large-scale and on a spatial basis development and urbanization, which leads to forest fragmentations, where parcels of forest land get smaller and they get more and more scattered. And that does have an effect, and this is a graph from a paper on forest fragmentation and sustainability that shows that the percent of forestry activity, that is managing forest, tends to decline with increasing population density. In this particular case, the x-axis is population density per 1,000 acres of the individuals per, and we see the more densely populated, the less likely it is that forestry is going to be practiced. So management approaches depend on your objective for your ownership. Is it maximum timber income, or is it managing for other amenities? Is it some sort of a blend? Your site characteristics, and we talked about geology and soil earlier. We're going to talk more in a few minutes. And the conditions, the current species that are present, their age, and the condition of the trees. Again, soils. And we'll see that soils may point a landowner or a manager in the direction of pine or more in the direction of hardwoods. And then the Silvics that we started out by talking about. That is the Silvics of the target species, especially the concept of whether they are a sun versus a shade-loving species. And then ultimately current and future markets. We mentioned earlier in an earlier presentation that forest landowners frequently ask us in Extension Forestry for presentations on markets, current markets, future, because you can't grow for markets that do not exist. And diverse markets where they exist, and they're getting more diverse, allow for more management options. So now we'll go drill a little bit deeper on ownership objectives. An owner can have economic values and interests, ecological values. There can be social values, especially for their family. They can have concerns about insects and disease, or leaving a family legacy, or wanting to use and promote the use of fire. They may be concerned about forest fire and wildfires. Rising property taxes can be an issue. And they can be concerned about an increase in regulations. And there are some that are negatively concerned. Some feel like, not most, but some feel like it may be a positive thing. But overall, landowners do have a willingness to embrace, at some level, land management. In fact, new owners are not averse to management, but many are more concerned about protecting amenities and ecological qualities than maximizing profit. And on a survey, in response to this statement, I would be willing to accept less money from a timber sale, if the logging actions protected other forest qualities, we can see that almost half said they agreed, 35% neutral, but actually only 16% disagreed with that. And we're seeing more and more of a trend in this direction. So now let's talk about Silvics and site characteristic considerations. So there are considerations with respect to soils, water, aspect, elevation, and slope, because they determine the optimum species mix, wood fiber yield potential, and the suitability for harvesting. So these are some very general determinations with regard to aspect and moisture regime and what tree species one might consider for certain combinations. For west to south facing slopes they tend to be warm and dry because they're getting they get more sun exposure than say in north to east facing slope, and because they tend to be warm and dry, species that may do best depending on where you are and what's there and other soil conditions, they might be scarlet oak, chestnut oak, black oak, and hickory as high as 4,000 feet of elevation. But we'll turn it around 180 degrees and talk about north to east facing slopes. They tend to be more cool and more moist because they have the least sun exposure. So for those slopes or aspects, species that may be appropriate might be northern red oak, white oak, yellow poplar, black cherry, white ash, and sugar maple as high as 4,800 feet. Now, this doesn't consider past disturbance, soil erosion, and things like that. These are very sort of general statements that we're making. In coves or drainages, those tend to be especially moist. On coves or drainages, one might consider or look at yellow poplar, northern red oak, white oak, black cherry, and white ash. So now we're going to layer on soil considerations. On what type of soils will the species or species groups thrive on? That's a question we want to be asking. And if we're talking in the case of timber production, are they capable of producing an economic crop on these soils versus just growing? And I know here in Wake County near campus, when I was teaching 422, Forestry 422, 522, I would often make a stop in the forest just south of campus, just south of Tryon Road, and we would go to a stand that had quite a lot of white oak that was growing underneath a taller canopy of pine trees, and I would ask the students what they thought of would be appropriate to grow on that site. And they would look around and they would see the white oaks and say, well, clearly the white oaks are here. For the long term, I would be managing for oaks. Now, that depends on what a landowner's objectives are for that land. But if in the case of timber production, the white oaks are not an indicator that it's a quality white oak site. They just happen to be there as an artifact from past stand management. But in fact, the sites were pretty eroded and would not have produced an economic crop of white oak because of the soils. So that's one example. So some factors to consider. You want to determine your optimum species mix, what the yield, fiber yield potential might be. If you're interested in wildlife habitat, what is the suitability of soils, certain soils and soils groups for wildlife habitat. And soils also are a determinant of what logging conditions might be in wet weather. if they're sensitive to mucking when wet weather, when heavy logging equipment is there, you would consider that a dry weather logging site only versus a wet weather that can handle logging in almost any condition. Also, whether it's considered erodible versus non-erodible, a best management practice selection, and what response you might get to fertilization. And notice the asterisk at the title, some factors to consider. Those bullets that I just listed are things that can be determined from an NRCS web soil survey. Those are all factors that you can glean from an NRCS soil survey. So you can answer those kinds of questions from your soil survey. Here's an example of a map from a soil survey showing the different series that are on a particular ownership here that's delineated with the sort of the teal line. So soil, there are groupings of soil series that are often broken out finer by things like slope or the degree of erosion, but soils can be quite diverse within a single ownership of land. But again, you can determine quite a lot from a survey, including the rating of a soil in terms of things like site index that we'll be talking about later. This particular table that you're seeing in the bottom right is a table that relates the soil series that are mapped to the upper left in terms of the quality of those sites for growing loblolly pine. Again, there are other things you can learn from your soil survey. This is one of them. So when we look at this column here, we see numbers, 82, 87, 87 for these different soil series that are mapped above. The number 82 means that in 50 years of age, you would expect a loblolly pine on this Ryan sandy loam on average to reach a height of 82 feet. But on the Wadowee sandy loam, B and D, the Wadowee B and D, you'd expect the average height within 50 years to be 87 feet. So that says this is a better site for loblolly pine, these two series, than that series right there. So that's an example of one kind of piece of information you can get from a soil survey. Well, soils, we've talked about soils as being one factor, but note that soils often can be the main factor in determining what species you want to grow. For instance, for pine sites such as white pine, loblolly shortleaf, pond pine longleaf, some typical series that tend to be really good for pines are appling eroded, sisal eroded, mayaden eroded, depending on what part of the state you're in, because when you look on your survey and you see it as eroded, that means eroded phase. So you can, for instance, have an appling soil that is uneroded, but if you see it as an eroded phase, that points you definitely towards pine, because pine tend to be the best choice on sites that have eroded phases, especially clay-type soils. So on these particular three soils where the soil survey says it's an eroded phase, pine may be the only choice that you can use. So again, we're making the point that soils can often be the main key. Now, if you happen to have an appling, sisal, or mayaden uneroded, Now your options increase. You can grow hardwoods and on all three of these, and you can grow pine, but you can grow pine better than you would if it were an eroded phase. If it were eroded phase, we said stick with pine. So you can grow pine better, faster if it's uneroded. And you do on those three soils if it's uneroded. You also have the option of growing hardwoods. Again, as examples, and there are many series in North Carolina, if you have Alta Vista, Chewacla, Congaree, alluvial floodplain and terrace soils, which there are, it's hardwood all the way. Those are great sites for their hardwood sites for growing yellow poplar, oaks, or ash. So soils in general for commercial species. On eroded upland sites, southern yellow pine, probably the best choice. We talked about physiographic provinces, of which the sandhills is one, where you have deep sands. Longleaf pine may be just about the only choice. It's certainly the best choice, even though loblolly often grows. On well-drained, deep upland soils, there you go. There are your hardwood sites. Yellow poplar, ash, most oaks. Wet flats in the coastal plain that are undrained, meaning they've had no artificial improvement through drainage systems. Willow oak and water oak are your best choice. They can produce a quality oak crop. Where they've been drained, which forest industry has done on wetlands, you may be able to grow loblolly pine. Well, in fact, many of those sites have terrific site index for loblolly after artificial drainage has been imposed. Bottomland soils that are normally well drained and are not inundated for a long part of the year. Some of the species that are good choices are cherry bark oak, yellow poplar, and that's the central part of the state in the west, and in the east, often sweet gum. For our coastal plain swamps down east, cherry bark oak, green ash, water tupelo, and bald cypress are not only good choices and the best choices, but also valuable species. In swamps with continuous flooding or flooding for long periods, bald cypress may be the best option. So now let's talk about Silvics for pine with respect to regeneration. Soils and landform, sometimes together, can dictate an only choice for species. As an example, for xeric or really dry, high elevation ridges in the mountains, Table Mountain pine may be the only choice. On higher elevation, well-drained, very deep soils, you have the choice of white pine or good hardwoods. In the eastern part of the state, where you have undrained organic soils, pine may be the only choice. We've already mentioned for deep sands, longleaf may be the only choice. And especially in the western Piedmont or mountains, lower elevations, highly eroded, bare clay soils with an adjacent seed source of Virginia pine, allowing the Virginia pine to reseed naturally, may be and often is the best choice. Let's talk about Silvics of pine with respect to regeneration for the most commercial species. Table Mountain pine, pine are not among our most commercial species. So now we'll talk about just the most commercial pine species. For loblolly pines, as we mentioned earlier, tend to be fast-growing from the seedling stage, which means that you don't have nearly as much concern about competing brush, competing weeds, competing hardwoods, because they get out of that low stage quicker than our other more commercial pine species. They tend to have good form if they come from improved varieties, genetically improved varieties. They tend to be relatively easy to manage, and they are our most planted pine species because of that. Longleaf. Longleaf pine has an initial grass stage that may last several years, and that presents some management challenges because of weeds that can get ahead of it, especially hardwoods if the site has a little bit better soils. But longleaf is a long-lived species. It can provide an option of a market for pine straw. It tends to have good form, and as we've mentioned a couple of times now, it may be the only choice on deep stands. Shortleaf, native to our Piedmont mountains, lower elevations. It's a bit slow the first years after planting, so it can present some early years management challenges, but it has excellent form and wood quality. It's a very dense wood species, and it does have some site limitations with respect to disease. Now we're going to talk about Silvics with respect to sunlight. One has to consider the sunlight needs of the desired tree species, especially with respect to regeneration, because there are some tree species that are sun lovers and there are some that are shade lovers. And this is a chart showing a continuum from shade lovers to sun lovers with those that are intermediate. So things like red maple, several hickories, sugarberry, dogwood, persimmon, beech, holly, magnolia, red bay, black gum, tupelo gum, slippery elm are definite shade lovers. They love to come in a shaded situation. And interestingly enough, they tend to be some of our most colorful fall color species. But because they're shade lovers, they tend to be species that often come in later in the life of the stand, once an overstory of sun-loving or intermediate trees have been developed. So for the intermediate, they include on wet sites down east Atlantic white cedar, bald cypress, also box elder, sycamore, white oak, swamp white oak, southern red oak, many of our oaks. I won't list them all, or they're listed here though. Won't talk about them all. But elm, several hickories, sweet bay are intermediate. Now for the sun lovers: red cedar, shortleaf pine, longleaf pine, pitch pine, pond pine, loblolly, Virginia pine. Well, there are your southern yellow pines. Birch, hickory, white ash, green ash, sweet gum, poplar, cottonwood, cherry bark oak, swamp chestnut oak, and some of the other oaks. Well, these are your sun lovers. They like to regenerate in open sunlight. Interestingly enough, of all of the species that are listed on that chart, the more typical, most valuable trees tend to be the intermediates, or especially the sun-loving species that are in that chart. And with this, this is the end of this video.